I'm going to go on and get started with this here. So, tangent of x. Do you have a question on 22 or 23? So, with any of, for these two here specifically, we want to get it equal to 0. So here, yeah, subtract square root of 3. Because we want to get the tangent, or the, in this case tangent, but the trig function equal to everything else. Because there's only one term here, it's tangent. We want to get it by itself. Now, if we have tangent squared and tangent, we have a squared term and a singular term, then we want to get everything equal to 0, factor, and go from there. Here, we just have tangent. So we get it tangent of x equals negative square root of 3. Well, unit circle. So square root of 3 is our pi, square root of 3 is our pi over 3. Now, incidentally enough, on the unit circle, pi over 3, any of the other angles that would correspond to it are actually going to be divided by 3. Now, in the first quadrant, you don't have to draw this. I'm drawing this so that visually y'all can see this. And if you're looking back on it, rewatching it, you have a visual. We have the 4 quadrants. And on the unit circle, tangent is positive in the first, negative in the second, positive in the third, negative in the fourth. And in the first quadrant, we do have pi over 3. In the second quadrant, we have 2 pi over 3, 4 pi over 3, 5 pi over 3. And really, whichever one has that 3 for pi is going to have the same value for tangent, because pi over 3 is square root of 3. Quadrant 2, our 2 pi over 3, is still the square root of 3, but it would be negative, positive in the third, negative in the fourth. So one of our answers is 2 pi over 3. The other one is going to be 5 pi over 3. So that's the nice thing with radians. If 2 and 5, or 2 and 4, yes. So what we're looking at is, because according to the unit circle, sine, cosine, tangent are all positive in the first. Second quadrant, sine is positive, ry, cosine is negative. Tangent, sine over cosine, a positive over a negative is going to give me a negative, because our positive negative makes tangent negative. Third quadrant, sine and cosine are both negative. Negative and negative make a positive. And in the fourth one, cosine's positive, but now tangent, or not tangent, sine is negative. Positive and negative give us a negative. So those two, it's negative. And because I know that our pi over 3, or any reference angles that are pi over 3, will give us the square root of 3, I'm looking to see where tangent's negative. Does that make sense? And the same thing holds true with pi over 6 and pi over 4. But that tells us these two are it. And if we want to make sure, I can grab the graphing, either calculator, make sure it's in radians. Tangent of 2 pi over 3. Need that second parentheses. Close parentheses, plus second square root 3. 0, just like we had it started out as. I can reselect it to bring it back down, or I could type the whole thing back in. And we said 5 pi over 3, which is 0. Because the other two, one of them is 4 pi over 3, which is just positive square root of 3, which gives us 2. Same would happen with pi over 3. Does that make sense? 23 is the same as 22. We need to get cotangent by itself. Now, even though the cotangent is being squared, there is no cotangent. We have a term being squared, and that's it. if we have a singular trig function that cannot be combined into one, where I have cotangent squared on both sides, well, we can move it over and they become a single term. If I have cotangent squared and cotangent, I need it all equal to 0. Almost like if we had an x squared term and an x term, we need everything on the same side, set it equal to 0. Here, we can get the term by itself. Telling us cotangent squared of x is equal to 1/3. At this point, we can take the square root of both sides, telling us cotangent of x is equal to plus or minus, well, square root of 1/3. We can plug this into the 30xs, but to do that, we do need to break the radical up into the square root of 1 over the square root of 3, which does give us the square root of 3 over 3. Now, most calculators don't do cotangent, if they're not that nice. Some do. But we know that cotangent of x is the same as tangent of x, but we have to flip it, which gives us 3 over square root of 3. And we can flip it in the calculator. 3 over second square root 3, enter, is radical 3. We get this here. And at this point, we're looking for tangent of x. What x value will make tangent be square root of 3? Now, we only had 2 in the previous one because it wanted what values of x will make tangent of x equal to negative square root of 3. Here we want positive or negative. And it said between 0 and 2 pi, so we're not even worried about the 2 pi in. That's it. Does that make sense? Two sine squared of x minus 1 and tangent squared of x minus 3. Two things multiplied together equals 0, so one of them must be 0. So for our sine squared, we can add 1 to both sides, telling us 2 sine squared of x is equal to 1. Divide both sides by 2, telling us that sine squared of x is equal to 1/2. Square root both sides. Square root of sine squared of x is just sine squared of x. Whenever we take the square root of both sides, we add the plus or minus. Since we do have a fraction inside the radical, plug it in. It'll tell us that it's going to be square root 2 over 2. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Because we have the plus or minus square root 2 over 2, we want all 4. Because really the only difference between those is the value, or the sign. Because pi over 4 is positive square root 2 over 2. 3 pi over 4 is positive square root 2 over 2. 5 pi over 4 and 7 pi over 4 is negative square root 2 over 2. And kind of a nice shortcut for that, especially with the unit circle, if you hopefully you still have it. If you don't, let me know. I can make another copy of it and get it to you because this is definitely helpful. If we're talking about square root 2 over 2, we're talking about our division of 4 with pi. I can get you another one. You can hang on to that one for now. But that's kind of a shortcut. Square root 2 over 2 is going to be our division of 4 with radians. Pi over 4, 5 pi over 4, 7 pi over 4, 3 pi over 4. Sine or cosine. That's our square root 2 over 2. We're just determining which one we need based off the sign. So we have those 4. Tangent squared minus 3. Add 3. So tangent squared of x equals 3. Square root tangent of x equals plus or minus the square root of 3, which is our pi over 3, our division of 3. Positive negative square root of 3. Luckily, the little chart at the bottom, or on the back, gave us that square root 3 for tangent is our pi over 3. So now we're looking at all the ones between 0 and 2 pi on the unit circle that have the division of 3 for radians. And we get these here. That's it. Does that make sense? Questions on this here? Questions on 25? Yeah. Let's look at 30 and 31. I will come back and do another video. 25 through 29. Make myself a note and post that later. So if you want to come back and look at those, you can. 32 sine of x over 2 plus the square root of 3. Since we don't have multiple terms, get it equal to 0. Or not equal to 0. Get sine by itself. Because if we wanted to, we could use the half angle formula. And the half angle formula for sine is plus or minus the square root of 1 minus cosine of theta over 2. If we can avoid that, I would avoid that. And we can avoid it here because I don't have any other sine terms. I don't have any cosine terms. I don't have anything else besides our sine of x over 2. So we can get it by itself. And it's telling us x over 2, sine of x over 2 is negative square root 3 over 2. Luckily for sine, we can just look at it, and there's 2 spots. One is at 4 pi over 3. Because we can add 2 pi in to it. Now, I know it says between 0 and 2 pi for these, for all this section. We need it because there's a good chance it might go outside, and we have to fix it. Because to get x by itself, we have to multiply everything by 2, which will indeed tell us x is equal to, but when we distribute the 2, we get 8 pi over 3 plus 4 pi in. Here we can do the same thing, which tells us x is equal to 10 pi over 3 plus 4 pi n. 8 pi over 3 is definitely bigger than 2 pi. So to fix this, I'm going to set n as -1 because n can be any integer, positive or negative. Is 8 pi over 3 plus 4 pi and n is -1. -4 pi over 3. So I'm feeling there's no way to actually get this between 0 and 2 pi. I'm going to borrow this. I think I just left it as is because that's an error I need to fix on 30. Yeah, I just left it as 8 pi over 3 and 10 pi over 3. Didn't even dawn on me that 8 pi over 3 is definitely outside. 10 pi over 3 is outside. Doesn't look like there's any value between 0 and 2 pi that works. So we'll leave it as this here. That's funny. That is funny. That was 30, yes? Error on 30. But questions on this here? $31. Subtract square root of 3. Yep. Notice it. Tangent of 2x is equal to negative square root of 3. Now negative square root of 3 is going to be our two pi over 3 and 5 pi over 3, if I remember right. First and fourth. Okay, so then square root of 3 is you're good. So up here is sine and cosine. So square root of 3, I look down here, is relating to pi over 3. So now I'm just looking at pi over 3. Positive 2 pi over 3 is our negative. 5 pi over 3 is our negative. Does that make sense? Yeah. Almost for tangent, because it's not listed directly on the circle, I see what is its reference angle, pi over 3. So all of our divisions of 3 work. Now we're just figuring out which one is in the correct quadrant. It's kind of a shortcut. The other method would be going around the unit circle and dividing those two as sine over cosine to get there. Now this one here, I'm gonna add the 2 pi in again, because luckily, starting out, these 2 pi over 3 is inside the circle, and it's fine. It works out great. So we're gonna divide everything by 2. X is equal to 2 pi over 3 divided by 2 is going to be pi over 3 plus pi n. We can do the same thing on the other side. 2x divided by 2 is just x. 5 pi over 3 divided by 2, you can do that in the calculator. I'm just going to go on and tell you it's 5 pi over 6 plus pi n. Now for this one here, when n is 0, it's just going to tell us x is pi over 3. If n is 1, pi over 3 plus pi times 1, 4 pi over 3. And both of those work. Both of those are angles between 0 and 2 pi. That will make this statement true. Now we could try a second one. Seven pi over 3, too big, because if the numerator for this one's greater than 6, we're done. So these two work. Other side, x is equal to 5 pi over 6. Let me do the same thing. 5 pi over 6 plus pi times 1 is almost. Because 6 would be 12. So this just works. So we have these 4 here. Because if it had been bigger, 17 pi over 6 is too big. One other way we could check to make sure, because it looks like it might be too big, is I can subtract 2 pi from it. If I get a negative angle, that means 2 pi was bigger. If I get a positive angle, it means 2 pi was smaller. Does that make sense on how to check that? Questions on this here? Again, I'm going to come back and do some more of the solving. I just want to make sure we get through the rest of this. Find the exact value of each expression. Plug it in. I'd plug it in terms of radians. We could use the equation. Just go on and plug it in. 7 pi over 6 minus pi over 3. Is 1/2. Because if we wanted to for 36, we would use the difference formula. And the difference formula says that we'd have sine of alpha cosine of beta minus cosine of alpha sine of beta. And then we look at the unit circle. Sine of 7 pi over 6 is negative 1/2. Cosine of 7 pi over 6, I believe, is negative square root 3 over 2. Yes? Then we look at cosine of pi over 3. Cosine of pi over 3 is 1/2. And sine of pi over 3 is positive square root 3 over 2. Negative 1/2 times 1/2, negative 1/4. Negative square root of 3 over 2 times square root of 3 over 2 would be negative 4 square root of 3 times square root of 3 is 3. Negative and negative make a plus. Negative 1 plus 3 is that's it. 37 is just finding sine of 7 pi over 6 and subtracting sine of pi over 3 from it. We can do these either way. You can plug them in or. Yep. Cosine of 135 minus, what was the other one? Because 135 and 30 are both on the unit circle. That's it. Right, each expression is sine, cosine, or tangent. So this one here, you are not finding the value. You are not finding the value on these because we're just rewriting them as sine, cosine, or tangent. The first one is our difference for sine. Now the question is, what's alpha and what's beta? Well, it's sine of alpha, cosine beta, cosine alpha, sine. So it'd be 3 minus 1.2. You can do 3 minus 1.2 in the calculator. It should give you sine of 1.8. And that's it. Cosine of 60, cosine of 15. Sine of 60, sine of 15 added together. This is our cosine difference formula. Alpha is 60, beta is 15, and we get this here. So I would just match it up with what the formula is and fill in the information. Tangent, well, plus, so this is tangent of alpha plus tangent of beta. Alpha is pi over 15, beta is 2 pi over 5. Pi over 15 plus 2 pi over 5. And this here, I mean, same thing for 46, would get cosine of 3x minus 2y. And that's it. Because for these here, it's not asking you to solve. It's just write the expression of sine, cosine, tangent. You just want it singular. And that's it. Does that make sense? This one here, just like the one on the test, you're just going to have to set up once. This once. You know, when I made the key on the test, I put this triangle or this setup in about the dead center. Because you can put it off to the side somewhere. I would put it somewhere where you can easily reference it. Find the exact value of each expression given. Sine of u is 24/25, where u is between pi over 2 and pi. U is over here. Sine of u, opposite over the hypotenuse. My brain is saying that it's the other one's going to be 7, but we'll see that here in a minute. Figure that out in a second. Cosine of v is -4/5, where pi is less than v is less than 3 pi over 2. Whoever wrote this was very nice and put these right next to each other. So we're going to have an overlap. Cosine, adjacent over the hypotenuse. Out of these two here, what's the other side for v? Positive or negative? Because which quadrant are we in? B? Yeah, 3. Thank you. I don't know why my head was saying 4. It is 3. You're right. Here, negative x, negative 1. Does that make sense? The top one, it is positive y, but our x is going to be negative. So we do need to find out what that is, and we could do it off to the side, saying a squared plus 24 squared is equal to 25 squared. 24 squared, 576, 625. I'm feeling that's 49. Seven. So it means the other side for u is -7. Yes? Okay. Sine of u minus v. Now, luckily for you, your writing utensil takes up less space than mine, so you'll be able to fit all this in, but I would just start going to the formulas now. sine of u minus v. That would be sine of u cosine v minus cosine u sine of v. They told us sine of u is 24/25. Cosine of v was told to us as -4/5. Cosine of u we didn't have, but now we do. The adjacent side is -7. The hypotenuse is still 25. Sine of v, the hypotenuse is still 5, but the opposite side is -3. Does that make sense how we got that? Because it's all based off this triangle. At this point here, we could do step by step out. (24/25) parentheses minus -7/25 parentheses -3 not that. There you have it, over 5. -117/125. At that point, let the calculator do it. Let it do the rest of the work. Plug all that in. Same for cosine of u plus v. Be cosine of v, cosine of u minus sine of v, sine of u. Well, we already had cosine and sine of u and v. Cosine of v is -4/5. Cosine of u, -7/25. Minus sine of v, -3/5. Sine of u, 24/25. Then we're going to multiply all those together. We're going to get 125 again. And this was -7/25 minus -3/5 24/25. Never mind. That's funny. 28 plus, and then it was, that makes sense. Because the numerators, because the 4 times 7 for cosine is 28, our 3 times 24 with sine gives us 100. 100 over 125. Yeah, so it did simplify. So questions on this here? Tangent, I'm going to move on without doing it, but again, all we got to do, come back to the triangle, opposite over adjacent for tangent, and we have them. If you do have questions over those, please ask. I can work them out, help you out there. I think we're getting closer to being done. Yep. Find all of the solutions on the interval of 0 to 2 pi. I'm just going to look straight at 53 because here we have a sum of 2 angles. So I'm going to use the sum formula. Sine of x, cosine of pi/6, plus cosine of x, sine pi/6, minus, same thing with our other sine difference formula. have them flipped. Just notice that. Because that should be cosine of x sine 7 pi over 6 equals square root 3 over 2. So what I did is plugged in our sine formula and difference formula into both and got to this here. Now, before we start fully simplifying, sine and cosine of pi over 6 are on the unit circle. Cosine is square root 3 over 2. So it's square root 3 over 2 sine of x. And sine is 1/2. Yes. So we get these here. I rewrote them so that the value's in front. Minus. Now cosine is 7 pi over 6. Is that negative square root 3 over 2? No, that's square root 3 over 2. Because we're down in the fourth quadrant.
Yeah, so
Or no, wait. We're back over here. They're both negative. So negative square root 3 over 2 for cosine, sine of x. Okay. Minus sine of 7 pi over 6 is negative 1/2 cosine of x. I mean, I can also radians. Sine 7 pi over 6 is negative 1/2. Now, two things are going to happen. One, here, the negative and negative make a plus. Then we're going to distribute the negative. So we will have square root 3 over 2 sine of x plus 1/2 cosine of x. Negative negative makes a positive square root 3 over 2 sine of x, but then we have negative 1/2 cosine of x is equal to square root 3 over 2. Our cosines are actually going to cancel out because positive 1/2 negative 1/2 makes 0. And what we have left is these two here. Now we will combine them to give us sine of x. However, square root 3 over 2 plus square root 3 over 2 becomes 2 square root of 3 over 2, which is just the square root of we'll get sine by itself. Square root 3 over 2 divided by the square root of 3. That's a funny fraction. All they just tell us it is 1/2. Now we're just seeing where sine is 1/2. Again, we can look at the unit circle. One of them is pi over 6. And the other is 5 pi over 6. That's it. Questions on this here? It got really big and then really small really quickly. I'll look at 5. So again, we're going to use our sum formula for this here. And this is one of those that's going to get big and then small. Because cosine of pi over 2 is 0 because it's straight up. So that is 0, which means this whole thing, not the whole thing, but that first statement is 0. Cosine pi divided by 2, 0. which means sine is 1. So it's really just telling us that we have cosine of x minus cosine squared of x is equal to 0. Now we already have it equal to 0. There is a greatest common factor between these two terms, which is cosine. So I can factor cosine of x out of both terms, leaving us with 1 minus cosine of x is equal to 0. Whenever we have two or more things multiplied together to equal 0, one of them must be 0. Cosine of x equals 0. Well, that's solved. We just need to see what values will make that true. Pi over 2, 3 pi over 2. We're going straight up, straight down. The other one, minus 1 from both sides, telling us negative cosine of x equals negative 1. Divide by negative 1. Cosine of x is equal to 1. Only one place where that works between 0 and 2 pi. 0. It's 0 or 2 pi, but in all the ones that we have, we include 0. We don't include 2 pi. Questions on this here? No, I took that out mainly because of the square sine of 2x plus cosine of 2x squared. It's not on the test. We don't have anything of that complexity, so I'm not going to worry about it for this here. 56. Let's finish up with it. I'm going to have to put a video together for y'all to be able to look back over and go from there. And that might change how things look for the sub. Yep, and y'all are gone for PLC. So let's do this together. I'm going to rethink things. Most likely I'll send out an email to y'all when I've come to a decision, and we'll go from there. Sine of 2x. Well, the double angle formula tells us that this is 2 sine of x, cosine of x, and it is being multiplied by sine of x is equal to cosine of x. Now we can multiply the left side, telling us that we have 2 sine squared of x, cosine of x is equal to cosine of x. Now there's different ways we can go about doing it. First, what I'm going to do is get this thing equal to 0. And as much and as tempting as it is to want to just cancel those cosines out, we cannot. Because cosine of x and 2 sine squared of x times cosine of x are not like terms. We can't just combine them as much as we want to. Now, the reason I said that there's more than one way we can do this is because, 1, sine squared of x is equal to 1 minus cosine squared of x. So we could replace that and go from there. But the reason I don't is what else is with our 2 sine squared? Cosine, yes? Do we have a greatest common factor? Well, they both have cosine. Those are the only two terms, yes? If, let's erase this. I had a constant term. Then I would replace sine squared with cosine squared and try to go from there. But I don't have another term. I do have cosine in common with both, because if I factor it out, what I'm left with is 2 sine squared of x minus 1 is equal to, I do have two things multiplied together to equal 0. So one of them must be 0. One of them is cosine of x equals 0. Three pi over 2. Straight up and down. And it's all in terms of cosine, so we don't have to do anything. 2 sine squared of x minus 1 equals 0. We do have to do some calculations with this, but I only have one trig function, so I can just solve it. I don't have to worry about trying to convert anything over. If we had had a number, like I had written in earlier, then we would have to do something a little bit different. Divide by 2. So sine of x equals plus or minus, it would be square root 2 over 2. And because of the plus or minus, we have all of our dividing by 4. So we have all these here. If there is a chance that one of the values will be extraneous, you will get a value that doesn't work, I will check your answers, I will put a note to do that.